Right, so we've got the M1 International Paper Inclined Planes question from January 2015. It's question 5. So we've got a particle P mass 2 kilograms pushed up a line of great slope, rough plane, horizontal force, magnitude X newtons, and it acts in the vertical plane, which contains P in the line of great slope. It's going straight over the plane. Plane's inclined to the horizontal at an angle alpha, tan alpha is 3/4, coefficient is 0.5, and the acceleration is 1.45, and we've got to find out what the value of x is. Right, so the force is acting on it. There's the weight acting down. There's the normal reaction. The friction's going down the plane because it's being pushed up the plane with acceleration of 1.45. Of course, we've got the x acting horizontally, and the coefficient of friction is 0.5, and the acceleration is 1.45 up the plane. So we're going to look at the forces parallel to the plane and perpendicular to the plane. It's going to mean F equals ma parallel to the plane because it's actually moving, accelerating. Right, so the x, I need to sort it out with the components parallel and perpendicular. That angle is alpha, so I've got to turn it through an angle of alpha to make it parallel to the plane. So that component is x cos alpha. That angle is 90 minus alpha. So I've got to turn it through an angle of 90 minus alpha. So that component is x cos 90 minus alpha. Now, the cos of 70 is the same as the sine of 20. Because they add up to 90. If you think about a right angle triangle, if that's 70, that top angle's 20. The cos of 70 is this side over this one, which is the same as the sine of 20. The sine of 20 is the opposite over the hypotenuse. So the cos of 90 minus alpha is the same as the sine of alpha. So that component perpendicular to the plane is x sine alpha. The weight, the 2g, if I look at the force, the components parallel and perpendicular, this angle's 90 minus alpha here. It's that angle there because you've got a right angle triangle, alpha, so that's going to be 90 minus alpha, which means that one's going to be alpha because these have got out to 90. So the component perpendicular to the plane is 2g cos alpha, and the component parallel to the plane is 2g cos 90 minus alpha, or 2g sine alpha. Now, if I look at the what's going on parallel to the plane, like I say, this is F equals ma. It's accelerating up the plane. So I'll do F equals ma. The x cos alpha is in sort of the positive direction, going up to the right, the way it's accelerating. So x cos alpha, and if I do the friction slowing it down though, so minus the friction, it's going in the direction of the plane, so I don't need to cos alpha or sine alpha that. The weight has got a component 2g sine alpha, so minus 2g sine alpha. So that's the total force acting on the particle. The x in the positive direction, the x cos alpha in the positive direction, minus the friction, minus the 2g sine alpha, because they're both going down the plane in the negative direction. That's equal to ma 2 times 1.45. Mass is 2. If you look at the forces perpendicular to the plane, well, the ZR is going up to the left. It's the only one. The x has got a component going down to the right into the plane, if you like. So that's the r is equal to x sine alpha and plus this component here, 2g cos alpha, because that's in down to the right direction. So the r is going up to the left is equal to the x sine alpha plus the 2g cos alpha. So I've got my two equations. I know that tan alpha is equal to 3/4. I want sine alpha and cos alpha really. So if I draw a little triangle with alpha there and tan alpha is 3/4 opposite over the adjacent the hypotenuse is 5, so sine alpha is 3 over 5 and cos alpha is 4 over 5. You could put in the calculator the sine of tan to the minus 1/3. That'll give you 3/5. But I like the triangle. Anyway, the friction is equal to 0.5 times R. Coefficient of friction is 0.5. So if I do 0.5 multiplied by this, of 0.5 x sine alpha, 0.5 times that, which is just g cos alpha, and then put the sine alpha in, which is 3/5 or 0.6, the cos alpha in, which is 4/5 or 0.8. So that gives me the friction, which I can put into here now, and then I'll be able to work out what the x is. So the x cos alpha is x times 4/5 or 0.8x minus the friction, which is minus the friction 0.3x and 0.8g minus 2g sine alpha. Sine alpha is 0.6. So 2 times 0.6 is 1.2. That's equal to 2 times 1.45, which is 2.9. I've got 0.5x here. And I've also got minus 0.8g, minus 1.2g. So I've got minus 2g on this side. So I'll stick it over the other side. 2.9 plus 2g gives me 22.5. And then I'll double both sides, and it gives me x equals 45.